Okay, real quick, just an update video. Previously, I had talked about having issues with using this AMD math coprocessor in my system. And I want to go through and talk about what I've done to resolve that issue. I believe I've resolved it, so I'll talk through that and explain that. Before I do that, maybe a couple of real quick updates that I'll just inject here before I get into the coprocessor stuff. I did make some changes to my Arduino code based on feedback and just some other things I was doing working with it. So if I jump over to that code just for a second, I had this queuing that I've got going on, and definitely there's some feedback that maybe that can further improve that down the road, and I do plan to work on that. But maybe the first change I implemented based on feedback is I changed the name of the methods for adding and removing from the queue to onQueue and dequeue. So a really simple thing, but I did like those names better than what I had that I was using. So that's been updated. And then I also, in the method calls, disable interrupts on the Arduino before I actually change anything in the queue. So I come into, let's say I want to add something to the queue. First thing I do is I disable the interrupts, and then I make the change, and then I re-enable interrupts. DQ, same thing, and even the has items, I turn off interrupts and then turn them back on, because I don't want an interrupt to be messing with this value while I'm in the process of reading it. So I want to read it first, then I'll re-enable interrupts. So those are some simple changes, and I had put that in, and almost simultaneously I had a comment on YouTube to do that exact same thing. So those changes have been added there. So minor things, but I thought I'd point that out. So if you see that in the code later. Also, my OLED screen, I was powering off of the main system power. I've moved the VCC for the OLED over to the Nano. So basically, when I apply USB to the Nano, that OLED can be initialized and be ready to go. And that way, when I turn on the system, I don't have to initialize that screen. I don't have to worry about waiting for the initialization. It's ready to go. And I'm finding that that is working much better. Which then gets me to the math coprocessor, which wasn't working great the last time I talked about it. And as a reminder, I was previously using this Intel 8287, and this is a non-CMOS version. And at some point, someone had commented that, shouldn't I be using the CMOS versions for the PPIs? And yeah, I should be. And so I have those on order, and they're still en route. So once I get the CMOS versions of the PPIs, I'll swap these out. But with that comment, I'd also caught that my 287 was a non-CMOS version. So I ordered CMOS versions. I got those. I pulled out the original and put in the CMOS version, and it really was not working, or it was flaky at best. So today I took a little time and tried to dig into and figure out what's going on there. One of the things I had to do is go back to the data sheet and just make sure I was understanding it correctly. And there was something I picked up a little differently as I went through it again today, and maybe looking for feedback if you interpret this the same way. One of the pins on the 287 is pin 39, called CKM, and that is a clock mode signal. And in my previous video, I mentioned if you tie it high, it uses basically the same speed clock as the processor. You can bring in the full system speed into it, and it would use the processor speed. And if I tie it low, it would divide it by 3. It would use 1/3 of the processor clock. That isn't quite right. So this says that when CKM is high, clock is used directly. When CKM is low, it's divided by 3. Okay, great. But if I go and read on the next couple pages down, they mention down here that you can either operate directly from the CPU clock or with a dedicated clock. And the 287 coprocessor functions at 2/3 the frequency of the 286. So it doesn't run at full speed of the processor clock. It would run at 2/3, or if I pull this low, it runs at 1/3. So I'm either going to get 2/3 or 1/3, depending on this pin that I set high or low. So that's how I'm interpreting this. And their example says, well, if you bring a 32 megahertz into the system, into the processor the internally is going to treat that as a 16. And it's 2/3 of that the actual coprocessor will run at, which is 10.6. Okay, that's great. And if I flip this to a ground instead of a high, then that means instead of 2/3, it'd be 1/3. And in this example, I suppose it'd be 1/3 of 16, so 5 1/3. So 5.3 megahertz versus the 10.6. Well, either way, if I do the math on mine, I'm running a 24 megahertz going through a flip-flop. So coming into the system is 12 megahertz. Processor's running, therefore it's 6. And if I come down here and whether I take 2/3 of 6 or 1/3 of 6, that's still well below the rating of this 10 chip. It's a -10. So initially I thought it was the clock coming in that had to be 10 or less. It's not. It's actually, I think, the way I'm reading this, it's, if I take 2/3 or 1/3 of the incoming clock, that has to be 10 or lower. And so if I'm going to bring 12 into my system, I bring 12 down to the 287, and that means that my processor's running at 6, and I take 2/3 of 6. That really means this is going to run at 4 megahertz with my configuration. I'm going to run the processor at 6, Mathco at 4. So 2/3 of 6 is my 4, which is well below the 10. So I think I'm plenty good to run this with this pin pulled up, where I'm saying use the processor clock directly, don't divide it by 1/3, just use the default 2/3. So if anybody's interpreting that differently, or you have experience to tell me that that's not right, but that's my read on how I'm taking this. So I can either use the clock directly or divide it by 3. And when I add to that the paragraph down here, it seems like it's going to take that clock, and I'm bringing in the full system clock at that. But they're saying, well, if you had used a 32 megahertz clock, that would get divided down to 10.6, which is 2/3 of the processor clock. So again, my math is I'm coming in with a 12. That 12 coming here means I'm running 6 to the processor. 2/3 of 6 is 4, so I'm going to have 4 megahertz here. 12 to the system, 6 here, 4 here. Okay, well that's helpful in my understanding, because that tells me that these chips are way fast for what I need to do. I'm not going to get to speeds like a 32 megahertz coming into the system and 16 at the processor. There's no way this is going to support that. But it should easily support what I have, and it shouldn't be an issue with the math coprocessor. And I didn't think in my last video it was a math coprocessor issue, but something incompatible with my system. So that's where I started probing. I got my scope out, and I just started working through and looking at what am I seeing for signals. And everything was looking good. If I had a probe on the address lines or the data lines or any of these other control type lines, it was all looking good. Until I hit escape on the keyboard and tried to actually do a call to it, and then everything would just kind of flatline. At that point, I would see flat address, flat data, and when I say flat, I'm talking 0 volts. It just basically stopped, it died. So maybe it threw, I don't know what it was doing, but that's what I was seeing on the scope. But one thing I noticed when I was going through and just testing was that, well, maybe let me back up. One thing I did notice, I guess, before I get to what I ultimately changed that I think fixed it, I did look at the outputs of my data transceivers, because I wanted to make sure, what did they look like they are having the right voltages. And I was seeing 5 volts on one side and 4 lower 4s on the other, and I thought that was a little weird. So I did, just for the fun of it, I took out all my HC chips, which would be 4 latches, 2 transceivers, and a NAND gate, and I put in AC versions. So I swapped out my HC with an AC, which is a little bit faster of a chip, but also has maybe issues that it can cause with that faster rise and fall times, as I understand it. But I put those in. That didn't necessarily help anything. I've not taken them out. I'll probably just leave them in, but that did not resolve the issue. So then I was continuing my probing, and I noticed if I had my probe on the clock line and I ran a call to the math coprocessor, I would get a proper result. So that told me pretty quickly I've got something with my clock that I need to see. Is it just a quality of the signal getting down here? Do I have a grounding issue? Is there something else going on? Now keep in mind, this is on a breadboard, so I'm running 12 megahertz through a breadboard, which isn't ideal. But I was figuring it was something to do with the clock. And if I go over to my data sheet, or not my data sheet, my schematic, sorry, and I look at maybe my clock generator up here, previously in the documentation for the clock generator, Intel recommends adding an inline resistor somewhere between 10 and 74. And I think that's both on the clock and the peripheral clock coming out of this chip. And let's see, I was running a 10 on the clock. So I had a 10 here, and I decided, well, let's just try a different value. And I tried a 46 because I'm using a 46 over on the peripheral clock, and that didn't help. And so I thought I'd try at the high end of this, which is 74. I didn't have a 74, so I put a 100 in. And that change made everything work. So I've gone from a 10 ohm resistor right here out of pin 10, and I changed that to a 100 ohm resistor, and now everything is happy. I've left the P clock resistor at 46. So I'm using a 100 and I'm using a 46. I did try 100 where the 46 is on P clock, and then that caused different issues. So I put that back to 46. I put this one at 100, and all the testing I've done so far is looking good. So I do have, looking at my math coprocessor, and I look at this pin for CKM, I have that CKM pulled high right now. So I'm saying use the full clock, full processor clock basically here, which I'm interpreting as it's going to run 2/3 of my processor speed. So it's going to run 4. And that is running fine. So I'm going to go ahead and turn it on, and we'll see if it's still running fine since I last tested this. So there's my initial startup. I can see down here, there's my output on the OLED screen, which I know you can't read on the camera, but it just says everything passed. That's great. Reminder, it's not really doing a lot of tests yet. These are just kind of fake messages for now. But I'm going to hit escape on the keyboard, and what I'm looking for is data that I'm going to send into a calculation and data that I'm going to get out of a calculation. And that is working, and that is the correct value that I'm expecting out of this calculation of an area of a circle. So I pass in a radius and I get back the area, and that is working consistently well. So basically, I think that's the change that ultimately made it work, because that was the last thing I did, and then all of a sudden it worked. And as I played around with different resistor values, I would break it again if I went too low, but at 100 it is working nicely. So I think that's it for this video. I just wanted to provide that quick update. I appreciate, I've had some suggestions on things to try to get that math coprocessor to work. And that's how I'm understanding the data sheet. And like I said, that resistor seems to have made the difference, and things are running well at this point. I can type on my keyboard, I can hit escape to rerun it. That's all good. All my SPI stuff is pretty clean at this point. You can see down here, when I hit escape, I write to that SPI. All the stuff I'm writing out to my Tera term, my serial out, is still working great. If I hit reset here, I can watch my post screen. It should re-sweep through that, and it did. I got back to my proper initialization there. I got this screen initialized properly. I can type on my keyboard. That's working. And then if I hit escape, math coprocessor is working perfectly. So I am happy. Math coprocessor appears to be good at this point. And I do think I dropped voltage down. Previously, in a previous video, I was saying that if I had all these LEDs on, I was running at about 1.5 amps. Without the LEDs, I think I was at 1.35. I'm now down to 1.007 amps as this is running right now. So that is the lowest I've seen this. And I don't know if that's all to do with just this chip or these other changes I made, swapping in the ICs. I don't know how that's impacting it, but I would say right now this is running with the lowest power I've seen it as a full system right now. And my expectation, I guess, is as I swap out these next two PPIs, that will also come down. And I do also notice that these CMOS versions are perfectly cool, whereas the older TTL version got quite warm. So that is also nice to see. So if you have any feedback on that, let me know. But I think ultimately the solution was a different inline resistor on my clock. I have had a previous recommendation to maybe consider, this was on my video card, but I think the recommendation could apply here. Should I get some type of a clock distribution IC in here that helps me take a clock and better distribute it to multiple devices instead of loading up this one pin with all of the devices that are using the clock? So that might be something I should consider. If anybody has further input on that, let me know, but maybe in a future update, I could consider putting in one of those types of chips that helps distribute clock signals to lots of devices.